Stroke WX. So bar WX is made of a magnetic material. Now Sarah magnetized the bar by using the stroke method as shown in the diagram 1 below. So when you see the term magnetic material, you must know that this means that this material can be attracted to a magnet, but it itself is not a magnet. So indicate the magnetic poles of bar WX in diagram 2 after it has been magnetized. So there's a before, there's an after diagram. So I'd like you to write this down now. You can use any color pen you want. Before and after. Okay? So, if this is supposed to represent my magnet, what this person is supposed to do, Sarah, supposed to do, is to keep stroking this way, using the same pole to stroke in the same direction. See? From left to right, left to right, left to right, left to right. So if this is truly the south pole, it should be attracting something that is north. Alright? So once it attracts north, you'll drag all the way. There's a north part here, the south part. I know this part you may not understand too much about the magnetic dipoles. I'll try to send you a video to explain this further. Something with graphics from something I can find on YouTube. Just take note that if this is south, you always attract north. Because remember, unlike poles, attract or repel? Come on. Attract. So if this is south, then therefore you will definitely get north here. Attract, drag across. So if this is not south but north, what will you get here? Of course, you will get south. Sarah then placed steel. I see the word steel. Remember earlier on in our revision, steel is a magnetic material. So she placed pins one at a time at 3 different parts along the bar WX after it has become a magnet, labeled P, Q, and R. P, Q, R. So this is at the 2 poles of the magnet. She continued doing so until no more pins are attracted to the bar WX. The diagram below shows the outcome of her experiment. So there are a few ways to understand this. What can she conclude from her experiment? Now, be very careful. You should call this part pole. This part is a pole. Pole is correct. Can you please write this down? Make sure you put a tick there, because now you're going to write down the wrong answers as well. Don't write things like N. This is questionable. Sometimes if we are going to be lenient, we may accept it, but this is not the proper name for pole. It is like my name is Mr. Long. If you call me teacher, I can choose not to respond to you because I have a name. Teacher is not my name. Teacher is my occupation. What is definitely wrong would be you say sides. Alright, side. Because there can be many sides to a bar. If this is a bar, this can be a side, this can be a side, this one. Alright, there can be 6 different sides to a cuboid. This is a cuboid. So don't use sides. Make sure you have written down all these options, and the only correct one is pole. Now one conclusion definitely will be this. Number 1, a magnet is strongest at the poles. There are 2 poles, right? So write down poles. You can also observe the middle portion. The second conclusion that you can have is this. A magnet is weakest at the center. Now I know a few of you mentioned that P is stronger than R, as in the pole P is stronger than R. That is also possible, but I'm not going to write this down, okay, because not because it's wrong, it is correct, but I just like to focus on these 2 because these are the 2 typical and understandable concepts that you can apply to all magnets. Whereas whether this pole is stronger than this pole or not, it just happened that it is true in this example. Next one, question 4, last question. Shalisa used an iron nail, batteries, wires, and a switch for an experiment. The diagram below shows the experimental setup. So this is familiar: battery, wires, coil around a nail, and we must highlight the material. This is an iron nail, and if this is and this whole setup is, what do you call this whole setup? It has a name to it. What is this whole setup? Try saying it. I'm not going to fill in the rest, alright? Because you should know what is this. 2 words. This whole setup will create this thing. Now, iron mail tells you this is a magnetic material. So let us be the smart lazy. Write it down this way. Magnetic material, our short form that we can learn to take notes. There's also a switch here. She placed steel pins. Again, I see the word steel. Steel is another mm. What is mm? Magnetic material. She placed the steel pins near to the iron nail, which has become magnetized hopefully, and recorded the number of pins that were attracted to the nail. She repeated the experiment 3 times and recorded the average of the pins attracted. Now this purpose here, you have learned it from primary 3, okay? You should know. By repeating the experiment 3 times means that you, what is the purpose? Write this down. Purpose is to find out if the results of an experiment is reliable or not. And she recorded the average of the pins attracted to the nail. Now this idea could be a new one to you, this part, the average of the pins attracted to the nail. I will explain it a little bit here. I'll try to do it again next time in a proper lesson. This is the first time that you probably come across this. This is to increase the accuracy of her results. What do you mean? For example, let's say if I try something for the first time. Let's say for test number 1, Mr. Long managed to score 10 upon 10. Hooray! My mother said I'm very good in science. Test number 2, I got 5 upon 10. Boo-hoo! Now my mom said that I'm not doing very well in science. I didn't study, I'm lazy. But then it's not true, I did study. It just happened that day, I don't know what happened to me. I was just careless, or I didn't sleep well. Test number 3, I got 10 out of 10 again. And my mom now is very sure that actually I did study, I did do well for science. It's just that this is a flip result. Because by looking at this and we average this out, 10 plus 5 plus 10 is equal to 25. There are 3 different tests. 25 divided by 3 is roughly 8. That means that out of 3 tests, I'm getting 8 out of 10. That is a pretty good score, isn't it? So that would indicate that I am not bad at science. That's the idea of the averaging. So we can help to manage problem that could be due to carelessness such as this. If the majority of the results give us something similar. She continued the experiment by increasing the number of batteries for each set of 3 trials before recording the results. The graph below shows the results of her experiment. So when she used 1 battery, she will put the the pins near to the nail. She will then record down how many were dangling down. This is something like doing this. But instead of putting pins at the end of the nail, but this is a magnet. To try to see how many get attracted to this, like this for example, like this, how many get attracted to this. Okay, with 1 magnet, maybe she got 1 battery, she got this. Then later on, she put 2 batteries, another 1. And now she realized, hey, the number now increased. Another pin, another pin, another pin. Right? Now, what was the aim of Shalisa's experiment? To know the aim, we must know what variable has changed. The aim, the clue to find this is in the changed variable. So what was changed? The number of batteries were changed, you see, keep changing. For example, 0 here, 1, 2, 3, 4, 5. Therefore, and what were the results that were being measured? Results were average number of pins attracted. So, to find out if the number of batteries used will affect. Now, this next part is tricky, right? This part really is tricky. A lot of students will get this wrong. A lot of you, if you can get the first part right, hooray for you. But the second part, you're likely to just write this down. Average number of pins attracted, because it is printed here on the worksheet. However, that is not the aim. Now, what does this tell you? If a magnet here can attract 3 pins with 1 battery, and when you put like 5 batteries, it can attract 20 pins. The number of pins attracted tell you how strong the electromagnet is. I repeat, the number of pins attracted tells you how strong the electromagnet is. Therefore, the aim for her, Shaliza, is to find out whether by increasing the number of batteries, will she be able to increase the strength of the battery. So to find out if the number of batteries will affect the strength of the electromagnet. That is the aim of our experiment. Remember I told you earlier on that this part here, this idea will always be tested when it comes to magnetism. How will it increase, how will you change the strength of an electromagnet? Increasing the number of batteries is one way, by increasing this. And how do you tell that it has increased? Well, by observing pins attracted to it, for example. So take note, this is the answer for part A. Next, why did she take the average number of pins attracted to the needle for every battery that was added to the experimental setup? I've given the answer here already. This is the answer. It is to increase the accuracy of her results. Okay, I'm not going to rewrite it aside. This is for part B. Last but not least, part C. What can she conclude from her result? Conclusion, okay, is always an answer to the aim. What was the aim? To find out if the number of batteries used will affect the strength of the electromagnet. More batteries, strength of the electromagnet increased because more pins could be attracted. Therefore, that must be the conclusion. As the number of batteries increased, the strength of the electromagnet increased. And that will be the answer for this. Complete a correction? All the best.